Good afternoon, and welcome to this webinar on lithium-ion battery safety. My name is Simon Hamlet. I'm the Senior Standards Manager for Built Environment and Fire at BSI, and I'll be chairing this session, which is part of a series of webinars that BSI is very pleased to be partnering with the Institution of Fire Engineers on. Lithium-ion batteries are at the heart of the electric revolution, and no doubt we all already have several of them in our homes and maybe even our pockets. A growing number of you will also have them in your garages. However, we're also all aware that lithium-ion batteries can present a fire risk, especially if they aren't used or charged in the way that the manufacturer intended. And as a technology that has only been used on such a large scale relatively recently, techniques and equipment for fighting battery fires are still evolving. Next slide, please. A bit of housekeeping before we get started. This is a listen-only webinar and it's being recorded. We very much welcome your questions via the Q&A function, and they will be answered after the presentations. If you'd like to ask a question, simply click on the Q&A button in the side panel and post it there. If you experience any technical difficulties, and hopefully you won't, then please submit your issue via the Q&A function as well. Upon completion of the feedback survey, BSI will send a link to the recording of the webinar in due course. This webinar is CPD recognised, and please request your certificate via the feedback survey following the webinar. Next slide, please. Here's the agenda for today. I'm very pleased to be joined by two experts who are going to share some of their knowledge with us on this important subject. Rob Harty is the Global Commercial and Technical Manager at BSI Assurance, and he's going to talk about certification for lithium-ion fire solutions. But first, Paul True, Technical Director of the Institution of Fire Engineers, is going to speak about battery technology and how fires develop. Paul, over to you.
Thank you very much, Simon. Good afternoon, everybody, and thank you for joining this webinar, taking the time out of your afternoon to listen to us speak about lithium-ion batteries. First of all, the Institute of Fire Engineers, Institution of Fire Engineers, most people in the profession will know who the IFE are, but essentially a professional body for fire and fire safety, as well as representing members from fire fighting sector too. It's been established since 1918, and it's an international body, so we've got international members. Next slide, please. So essentially, I think I would like to break it down into three groups. There are many more, but there are three sort of larger groups. So the sorts of people that we represent are fire risk assessors, fire engineers, and firefighting experts. As I said before, there are a wide range of different areas within fire. However, that's how I personally would break down the larger groups of the people that we represent. And when it comes to lithium-ion batteries, every one of those individuals will have a different view and issue associated with their sector and their element of dealing with batteries. And for example, we have our fire engineers and indeed our fire assessors that are coming to us and saying that we've got a number of people asking how we can install vehicle battery chargers or vehicle car chargers into their existing buildings, in underground car parks and car parks associated with those buildings, indeed multi-storey car parks as well. And with reference, as I'll come on to later in more detail, the firefighters and firefighting sector, when the vehicle battery, for example, does catch light, how they can deal with the fire itself and the difficulties associated with that. Next slide, please. So it's very easy to talk about electric vehicles and the battery associated with those, electric scooters and electric bikes and other small modes of transport. I think it's worth mentioning bulk energy storage as well. Mentioning, so you can see on the left,
sorry, Paul.
is and you can find, yeah.
Hi, Paul. I think we're just losing your audio a bit, so it might, if I just advise to turn your camera off, it might help with the bandwidth, if that's okay.
Sure. Is that, can you hear me now?
Yeah, great, thank you.
Can you hear me okay? Thank you. Sorry about that. So essentially what I was going on to there was, it's worth mentioning bulk energy storage systems. So it's easy to talk about electric vehicles and the fires associated with those and scooters, very high profile, they've been in the news. But it's also worth noting that going forward, you have the possibility of these types of bulk energy storage cropping up. So on the left-hand side of the picture there, you have the large-scale bulk energy storage, which you can find in hospitals or at hospitals and places like Heathrow Airport and other big infrastructure type places. And the one on the right, the image on the right, is a domestic style battery energy storage system. So you'll have that placed on the flank wall of your home on the right hand side, and that will potentially power your house throughout the evening once the solar panels have had the opportunity to charge it throughout the day. Obviously not necessarily in the UK because we don't have much of that sun stuff, but it's essentially that's the plan. Next slide, please. Okay, so this is a schematic of a vehicle, and I'm just going to go through some of the processes associated with the cars themselves and some of the potential issues that you may get with charging and if one catches fire. So next slide, please. So on the left-hand side there, you see the power supply come up there. That's could be through fast charging, it could be through normal pace charging, or it could be through plugging it into your domestic supply at home. The fast charging is very much advertised by electric vehicle manufacturers, and it can, as we probably know, charge your vehicle up to 80% relatively quickly in the grand scheme of things. Well, certainly compared to a 3-pin plug. For you to stop and then recharge and then head on your way for the rest of your journey, hopefully. Worth noting that every fast charge that's put into a vehicle has an effect on that battery, so it can degrade the battery itself. There's loads of chemical interactions and events that go on, both in charging and also when it comes to the process of thermal runaway, which I'll come on to later. I'm not going to get into the technicalities of all that because I think fundamentally the purpose of this presentation is to talk about awareness and what we can do about to changes going forward. Next slide, please. So as mentioned, whichever mode of supply you choose, the sole purpose of that is to obviously recharge the battery so that you can head back off on your way. Worth noting, actually, going back to some of the people who represent the power supplies that are being installed into domestic premises in particular, there are a number of courses that people can go on to train on how to install these chargers at home. And that's fine, but the issue that we've found is the vast majority of them will put the charger at the most convenient point to the property, i.e. perhaps just outside the garage or just outside the front of the house or the property itself. Very convenient, very fortunate. You can just park your car up on the drive and it's all there and you can plug straight into it. Problem is if that then goes wrong, obviously then then we're talking about the you know, a battery fire, lithium-ion battery fire, and indeed car fire just outside your front living room window. So obviously it's worth noting that, you know, there isn't any awareness as far as I'm concerned in terms of the training that's put these people are going through. They just tend to have the training, the connections and the supply detail, but not necessarily any awareness of fire safety. So there's some education that needs to be carried out there. Next slide, please. So the sole purpose of this process is from the power supply through to the battery is to power the electric motor, which obviously, or motors, depending on the vehicle that they've got, and then that will give you your drive. Next slide, please. So battery box construction. Each battery box is split into two. So the batteries, the cells themselves can be placed inside, and then the lid essentially goes on and it's sealed with a seam gasket. So in the event of a fire, you'll have seen, and we'll come on to slightly later, a number of options in terms of extinguishing or controlling a battery fire in a vehicle. Next slide, please. That's often there's also a rapid overpressure vent as well, which is ventilated. Next slide, please. So essentially, if we do get a battery fire, you'll have seen a number of methods potentially of extinguishing. There are blankets that people suggest you can apply to the vehicle itself to contain the fire. Obviously, it doesn't extinguish it, but it contains it within the vehicle itself, the perimeter, and stops it hopefully spreading to other vehicles and various other methods we will come on to. But the issue with that, potentially, if you do the next slide, please, is if the seam goes, you can get a shaft of fire 2 to 3 meters from the vehicle. So it's extremely difficult for firefighters to get close to a vehicle, certainly in the first instance, but also fundamentally when it comes to extinguishing the fire is taking place largely inside that box, the battery box itself. Next slide, please. And continue to the next one. Thank you. So the overpressure vent, as it says there, will be released at 2 to 3 bar. A significant amount of pressure required for that vent to initially give way, and that in itself creates a big spread of fire and nasty chemicals that are coming out as a result of the thermal runaway going on in the battery box. So extremely difficult for firefighters, extremely difficult for car park operators to factor in this sort of issue, and how close do you park the vehicles, where are the electric vehicles being charged and compared to internal combustion vehicles, etc. Next slide, please. So looking at the tactics that can be employed at the moment, we go down to the bottom first, where you can see the images of the batteries there. The cell failure, whichever mode that may take, it could be overcharging, it could be wear and tear, it could be damage for an accident or other types of structural damage. Those things can lead on to a thermal runaway. Once the thermal runaway has started, extremely difficult to stop, which leads to the propagation of a fire itself, and then that self feeds on itself to create yet more thermal runaway. So going over to the top left, the green banner there, many fire and rescue services are doing a controlled burn, as it says, and just protect the surrounding area with copious amounts of water. Some instances have taken up to 24 hours to deal with, so again, extremely resource intensive. Other options on the bottom left, the high pressure systems, that's been mooted as a potential solution. Clearly, any sort of efforts of extinguishing the fire, as I mentioned earlier, the fire is taking place inside the battery box. The battery box itself is designed to keep water out. So just by spraying water at a sealed box isn't going to extinguish any fire. So the high pressure lances, the theory is the high pressure lances can penetrate the vehicle, penetrate through into the box, and then give access to the battery itself. However, supplying the high pressure water into a battery box isn't necessarily the most efficient means of extinguishing anyway. In the middle at the top, you've got blankets. So this has been widely discussed as a containment type solution, as I mentioned earlier. There is some benefit in that, providing you can get access to the vehicle. In this instance, in the picture, they've got an old vehicle that isn't an electric vehicle, and it certainly isn't on fire. When you go back to the earlier image of a 2 to 3 meter shaft of fire coming out of the side of the vehicle, I'm not sure they will be doing that quite so neatly. And also the potential, the relief valve as well. I think equally that would be slightly more difficult too. Over to the right hand side, other inventions have been piercing and cooling. So slide the equipment under the vehicle itself, pierce through into the battery box, and apply cooling water or fluid to that. And on the bottom right, an immersion container where they literally fill it up with water and immerse the vehicle, or the other way around, get the vehicle into the container and then fill it with water, and then completely smother it for extended periods of time to ensure that thermal runaway is finally stopped. Next slide, please. So we've talked about battery energy storage systems, large scale and domestic. We talked about electric vehicles, and obviously that can include buses and all sorts of other vehicles as well. In the group that I'll mention later, we've got organisations like the MOD and Heathrow and all those sorts of large organisations and entities that are dealing with all sorts of electric vehicles. Using Heathrow as an example, the baggage handlers and the stairs that they drive off out to the aircraft and that sort of thing, all going over to battery, lithium-ion batteries. So there's a wide range of large scale items. But looking at this image, obviously you've got bicycles as well as scooters, very much in the news. Unfortunately, sadly, there have been fatalities as a result of charging these types of vehicles in hallways and corridors. London Fire Brigade actually stated that this type of fire is the fastest growing type of fire, unfortunately, and that's just by nature of the industry and the popularity of these sorts of vehicles. But bottom left, you've got vapes, very common, disposable even vapes that are designed to be used once or twice or however often, and then thrown away. So they get put in the bin, they go off through the recycling process to recycling centres, they get squashed. Recycling centres are catching light all the time. Before I joined the Institute of Fire Engineers, I was in the London Fire Brigade for 27 years, and I personally have stood around many a recycling centre in London that's been ablaze for a long, long time, largely, I think, due to the unwitting disposal of these types of things. And it is about educating people, educating the public as well as industry in the sorts of effects that disposing of these types of batteries and the use of these types of batteries and the charging and of these types of batteries can impact on industry itself and individuals and indeed lives. Most of us have got mobile phones, laptops, equipment, tools in general. All of these items, household items, contain lithium-ion batteries of some sort. And if you were to walk around your house and take stock of what you've got, I'm sure most of us, me certainly included, would have quite a number of these types of batteries in our homes. Next slide, please. So on the educational piece, for members of the public in particular, if we're talking about e-scooters and e-bikes, the blue CE on the left-hand side is the marking for the safe manufacture of goods in the European region, so European regulations and marketing. The red image on the right-hand side simply points out that it was a Chinese import, and it's, you know, it was a product manufactured in China. And if you're stood in a store or looking on the internet and you're thinking about buying an e-scooter or an e-bike or anything like that, and you've been told to look out for the CE marking, it would be very hard pressed to know the difference between the two. You know, it's very easy to you know, see the image on the right hand side and think that that's meeting the European standard, and it isn't. That isn't to say that every item that comes out of China isn't safe, because it could well be. And in fact, as some people will know, the MG mark, the MG car mark, is a Chinese produced vehicle nowadays, and marketed over here, and there are loads of them on the roads. That doesn't mean that, as I say, an item made and manufactured in China is not safe, but there are a number of examples where, you know, items from, you know, less reputable companies have made it over here and indeed are not safe. Next slide, please. So 3 years ago, when I first started with the Institute of Fire Engineers, I started as technical advisor, and I was asked to look at electric vehicles and emerging technologies. And my brief essentially was to be a coordinator, essentially. In other words, you know, have a look and see what's going on out there in industry, see who's working on which area of electric vehicles and emerging technologies, and act as a conduit, if you like, for information. It was put out via the IFE magazines that I was working on this area, and we were absolutely inundated with people looking for information. Very quickly realised that just acting as a conduit of information wasn't going to cut it. So I set up a electric vehicles and emerging technologies interest group that's been sitting. We sit quarterly, and it's grown exponentially over a very short period of time. And just to give you a quick overview, that there are some of the organisations listed there that are part of this group, and it's the golden thread going for all this is obviously lithium-ion batteries. And you know, if you was to look at the nuclear industry there, you've got Sellafield is one of the members. They have robot, they call them dogs, but essentially they're a small robot that goes into areas that are not safe for humans, powered by a lithium-ion battery. You know, they've joined us with their concerns that if they put one of their robots into an area that is not safe for humans, and there's a lithium-ion battery fire, then what do you do? We don't know the answer to that, by the way, but these are the sorts of things that we've got, you know, in our discussions. Liverpool tunnels, Transport for London Fire Brigade themselves, both in their policy department and their fire safety department. There's a huge, you know, ask from industry around, you know, how we can, what do we do in terms of lithium-ion and how we extinguish them, as well as representing, as I said earlier, fire safety inspectors and engineers. Next slide, please. So the future, this is an interesting one. So there is a widely thought view that perhaps lithium-ion won't be the solution going forward. It's manufacturers, when they, or industry actually, when they see an opportunity, they'll develop other opportunities and other systems. So lithium-ion batteries have been a good starter, if you like, notwithstanding the issues that we're talking about today. But there are other types of batteries being developed, and industry will always step up and look for alternatives once there's a market for that. I think the market has been identified, and I've got every faith that industry will start the development process and develop alternatives. And the example I always use, quite a few years ago, we were told we couldn't use incandescent light bulbs, and in favour of these little small wiggly light bulbs that were posted to you for free. That, you know, when you put them in the socket and switch them on, probably 15 minutes later you had enough light to traverse the room. Industry came out with the LED light as a result of that, which was instantaneous and low on electricity consumption. So I'm kind of linking that as a you know, similarity, and perhaps industry will respond and we will come up with another solution. As far as standards are concerned, you know, there are so many different standards that need to be considered. First of all, I think the manufacturers and others need to admit there's a problem, and I'm not sure they do that currently. But you know, as far as standards are concerned, I've mentioned about public awareness, the charging of vehicles and equipment and anything associated with lithium-ion batteries, the construction of the batteries themselves. There's a huge amount of, you know, standards that need to be confirmed and set out for industry. Next slide, please. That's it from me. Thank you very much. I'd like to introduce Robert Harty, who's going to do the next presentation.
Right, thanks, Paul. So I wanted to start by talking about electric vehicles again, and just giving quite a balanced view of the fires and some of the challenges that are faced. And throughout, I just give a perspective of product certification and what we're doing for that. So Sam, if we're able to move on to the next slide, please. So yeah, just reflecting on the Nissan Leaf, which has been with us for around 14 years now. And in that time, it's been relatively safe. There's only been 7 recorded fire incidents. But the introduction of more sporty, desirable EVs has increased the attention for this segment of the market. And the hype for cars like Tesla has come with it some association for catching fire and some more interest in that issue. And there's even a website reporting each and every fire incident as well. I work in BSI's product certification division, where we put products and services through their paces to ensure that they meet or exceed the latest best practice. A couple of years back, we started receiving inquiries for certification for the latest EV fire suppression technology. And every inquiry seemed to be focused as well on extinguishing a Tesla. I live very close to Luton Airport, so I was really keen to follow developments of the fire in the car park last year. 1,500 cars were affected and planes grounded. And so ingrained was the knowledge that EVs spontaneously combust that there was an automatic assumption that the fire was caused by an EV. And the breaking news story was that it wasn't in this case. Bedfordshire Fire and Rescue confirmed that in a statement as well. Battery innovation and the uptake is running at such a pace that we're struggling in some areas, such as fire protection, to keep up. Battery fires amount to a massive challenge across all aspects of our daily lives, be it in our homes, workplaces, and the transport we use. And so we need new solutions. The EV car manufacturers are really keen to point out that fires per million miles driven in their cars are much lower than the average combustion engine car. And there's several reports to back this up as well. The problem is when batteries do catch fire, they bring additional problems, both in terms of the intensity and the ability and time to actually extinguish them. The EV stock on our roads is relatively new. So what kind of happens to those fire statistics as those batteries begin to age? The Nissan Leaf is one of the original EVs, and its first generation batteries are famous for the degradation in short ranges. So what do we do with all these batteries, and what will happen when the newer, higher capacity batteries with different chemistries reach the end of their serviceable lives. The Luton Airport fire started by a diesel car, but was undoubtedly made more difficult by EV batteries cars on site. And there are a number of developing strategies to deal with lithium-ion fires. But as we stand today, there's very little product certification available for suppression technologies. There are a few proven test methods to validate performance claims. Standards, though, provide the blueprint for best practice, but they're still in development. So if we can move to the next slide, please. Our mission then in BSI product certification became to provide something to the market. Our mandate is to provide societal impact. And we had lots of experience with fire suppression, but not with lithium-ion battery fires, as that was all new to us. And we're not going to certify anything until we have a firm understanding of the subject. What we do have at BSI is a really privileged position where we're able to convene industry. So we embarked on an investigation, gathering information and opinions from experts. We also have an electrical laboratory, so we pulled in knowledge from our own experts as well. Gathering this knowledge helped us to contribute back to the standard committees to develop those much needed test and validation methods. Our nominated experts are contributing to BSI committees, FSH 17 and FSH 2. But to deliver societal impact, we're going ahead with what we can do today, but we're certainly not jumping in with electrical car fires just yet. We're starting much smaller than that, and it will set us on a trajectory as well to tackle the larger battery installation suppression in the future. So then I'm going to be taking a really candid approach to share our current limitations and also what we're working on in the future. So if we're able to move on to the next slide. It would be remiss of me not to start with a statement that prevention is better than suppression. So to emphasize this, I wanted to spend a moment recapping the failure mechanism, because when an individual battery cell goes into thermal runaway, there isn't really a good way to stop them. And there may be some indication thought by swelling, a voltage drop, and then ultimately some off-gassing. The actual construction of larger batteries is for multiple cells in a pack. And it may be very difficult to detect a single cell going into thermal runaway in that larger pack. And when they do catch fire, the release of energy can be sudden and violent. Suppression, where the extinguishing can actually be applied to the battery, then stops propagation of that fire. And the thermal cascading is where the thermal event of one battery then compromises the separating layers of adjacent batteries, leading to short circuits, spots where there's huge high resistance as current surges from the anode to the cathode, and then spot heating results. The separator between the cathode and anode can be affected at temperatures as little as, say, 100 degrees. And as each cell affects the next, like a domino, it creates that domino of explosions. So just really, because it's so difficult to stop that reaction, that's why I really wanted to mention about prevention. BSI offers kite mark certification for batteries to make sure they're safe. And starting in August this year, manufacturers have to affix the CE marking to each individual battery in order to place the product on the European market. It's worth noting, though, that in Annex 8 of that directive, the involvement of notified bodies is only for the health and environmental protection requirements. So specifically, that's for Articles 7 and 8, which is more to do with carbon footprint and circularity. So if we move on to the next slide, I wanted to share my own very recent experience with a faulty battery. So I found this battery in a drawer in my house last week. It was swollen, and the case was buckled and opened along both sides. And maybe it wasn't going to explode. I don't know, but I sent the picture to our experts in our lab team, and they told me that probably shouldn't be using it. If I were to move back, that's great, thanks. So we got this battery as a giveaway with a phone contract renewal, and it's branded with a recognisable name, but I have some doubts. It has a CE marking as well. So safer batteries definitely are the way forwards, but there'll always be a need, I feel, for additional assurance to deal with issues when they occur. So if we were to move on to the next slide. So this is how we arrived at our certification offering with the smaller batteries. So after careful evaluation of the market, we arrived at where we can deliver most societal impact. And we've chosen to focus currently on e-scooters and lithium-ion batteries up to e-scooter battery sort of size. So we're going to move to the next slide. Government policy in the UK has really been to promote walking and cycling. And there is an investment strategy around this, mainly for promotion and the creation of connected cycleways, which is a great aspiration. Human powered transport certainly is green, but people still do what they want. Those cycle paths are just as likely to be used by e-scooters and e-bikes. And these devices are going to be on our roads and pavement, and they are a problem. I'm not quite sure what the legal status is for these either. The fact is, though, that people use them. The government may prefer e-rental schemes to supplement the public transport network for that final mile, but and this is potentially so they can, ensure that they are ridden at a safe speed, but people are going to do what they want. The Parliamentary Advisory Council in 2022 reports that it estimates 750,000 e-scooters in private ownership. And just observing our town centres, you can see that private ownership is largely winning. So before we invested into a certification scheme for battery fire suppression, I spent a lot of time investigating to see if things like e-scooters were a fad like hoverboards were. But one of the biggest indications to me that they're possibly around to stay is that government regulation around them seems to be softening. To be able to move to the next slide. Fires are really a problem for e-scooters. The number of e-scooter fires has been increasing. The London Fire Brigade that they attended on average one every other day last year. TfL in London was so concerned that in 2021 they banned e-scooters on their entire network. Young people and gig economy workers seem to be the most affected. Just think about how these e-scooters are used. The batteries are predominantly located in the floor of the e-scooter, close to the ground, so they can be affected by going up and down curbs or maybe stone strikes if not protected properly. The fact is there is cheap, unregulated products on the market. E-scooter batteries are quite a bit bigger than the swollen battery I showed earlier, about 20 times bigger. When I work in product certification, I value the quality, and through circumstances, a lower quality battery pack still made it into my home. It's possibly not a focus of most people. Really, is a gig economy worker going to pay a premium for an e-scooter with third-party certified battery? Or are they more likely to spend money on making it go a bit faster, to modify it, or a bigger battery to go a bit longer between charges? They're more likely to fix broken parts with replacements. The internet is great. It's a convenient place to get components at the right price. Incorrect chargers are possibly the leading cause of fires. The connectors may be the same, but the frequency and the voltage might not be quite right for that battery, which could lead to a fault and a fire. To compound the issue, e-scooters might also be charged overnight in corridors and communal areas. So I've kind of held up this kind of fictional gig economy worker as a straw man, not necessarily as the cause of the problem, but with empathy for the kind of rational actions and some of the solutions that industry needs to provide. So if we're able to move on to the next slide. So we've focused on battery sizes up to 600 watt hour as typical in privately owned e-scooters. The challenges and considerations are similar for electrical items with batteries up to and including this size. So, I mean, consider what happens if you drop a battery-powered tool, for example. Mechanical damage to the cell could mean the internals are compromised that create a short circuit. It only needs to be a single cell that has an issue for it then to develop into a full-scale failure of that battery pack. And failure might not necessarily be immediate. In fact, it's regularly reported as being quite delayed, so probably best not to put back that tool that's just been dropped back with the other spare batteries into the work van. Fires from these batteries are really different to the fires that we're familiar with for wood, plastic, and heptane. The packaging of the battery obscures the application of the extinguishing. And this is another reason why we're not quite ready to tackle EV fires in respect to product certification. I mean, EV cars are essentially, or the batteries in them have the whole car packaged around it. It is less significant for things like e-scooters and electronics, but still represents a problem. Also, as mentioned earlier, failing batteries produce an array of nasty gases, even before they go into a full explosion. Hydrogen fluoride is particularly nasty, as it can produce hydrofluoric acid when it comes into contact with water, like the moisture in your eyes. The failure of a battery can be slow and the warning signs can vary, but when a cell goes into a thermal runaway, the actual explosion can be really violent. And there's lots of different battery compositions that will affect the ferocity of the explosion, and different electrolytes in the battery are also going to contribute. The sudden release of energy can create projectiles, which is just dangerous in itself, but can also create secondary fires. An eyewitness statement from a house fire in Blackpool last year reported it was like a Roman candle. And batteries, once extinguished, can reignite. Any remaining cells in the battery packs may still hold energy, and the separating layer between the cathode and anode could be compromised. So if we can move on to that, thank you. So BSI certification, we have a protocol for small lithium-ion suppression, and it's limited to portable fire extinguishers. So this is the perfect place for us to start, as we are the market leader for portable fire extinguisher certification in the UK. And we are utilising NCA 8133 in addition to our kite mark certification scheme for fire extinguishers. Now, this is very much an interim position for BSI product certification, whilst European EN standards are in development. NCA 8133 is published by NEN, Dutch national standards body, and represents the best practice available to date for lithium-ion fire suppression for these products. It may not fully address all of the risks associated with lithium-ion batteries, and it's important to be candid about that, but absolutely is the best available to date. At BSI product certification, we've taken the position to not offer lithium fire suppression as a standalone certification for the extinguishing medium. The scope of our certification is for a portable fire extinguisher, which may well be used to showcase the capability of extinguishing medium. Our certification for the fire extinguisher, however, includes the full requirements of EN3 because, as we mentioned in the last slide, the battery has packaging. Normally plastic and secondary fires of other materials are possible. So EN3 is the European standard for portable fire extinguishers. And the route to certification is shown on this slide, left to right, starting with pressure equipment certification, as it's the minimum regulatory requirement for placing fire extinguishers to the UK market and EU market. Next are standard kite mark certification in accordance with EN3 as a requirement, and it is a really tough requirement as well. And only once that's in place, we then have the compliance certificate, kind of like a bolt-on for the lithium-ion fire performance. And it's important to note that the fire suppression performance, as documented or limited on our certification, is for the actual unpackaged battery as tested. And if we're able to move on to the next slide. So finally, I just wanted to finish by sharing our direction to provide a certification for fire suppression systems to protect energy storage systems. If we move on to the next slide, there's been an increase in energy storage systems, and it's to service energy spikes and the production profiles of renewable energy. So those grid scale batteries have been implemented. They need to be positioned close to the cities they service, but there have been a number of high profile incidents that mean residents are less than happy about them being located near them. So you might be familiar with the term NIMBY, not in my backyard. Well, some of those high profile fires have given rise to action groups, really concerned about the potential for explosions and toxic gases. The picture here shows a 10 megawatt hour unit that failed near Liverpool in 2020, and it took 11 hours for the fire brigade to extinguish it. The reality for certification bodies is that we're a little way off actually being able to provide certification for extinguishing methods. The standards are needed to be able to support that. So as I mentioned earlier, BSI is contributing to FSH 18, which is currently investigating different test methods to be able to certify different suppression systems for grid scale batteries. If you're able to move on to the next slide. There's really some factors driving domestic energy storage systems. So even if the weather in the UK can be a bit gloomy, there is still a case for the uptake of solar panels on people's homes. The International Energy Agency rates PVs, so solar panels, are one of only 3 technologies that are on track to support the 2050 climate change targets. The price has decreased significantly. They can purchase a panel for as low as £100 in some cases, and the performance has also increased. And testament to this is the uptake of commercial ventures to turn greenfield sites into solar farms. And business isn't going to invest in something unless it's financially viable. There are only 3% of eligible roofs in the UK that are fitted with solar panels. It's a small number, so the energy produced is manageable for the grid and currently is sold back to the grid. All very well, but possibly not viable on a larger scale, as the midday energy production profile of solar panels isn't quite aligned with our usage. So if the incentives given to households from the energy companies change, then there may be more of an uptake on domestic scale battery packs. Now, I looked at one of the bigger manufacturers of these, and in their fitting instructions, the recommendation is that the battery pack does sit outside the house, but that's a recommendation, meaning that inside is also possible. So certification for safer batteries, better containment and best practice is needed. Recently, BSI has worked on a PAS 63100 for domestic battery energy storage systems. Certification for suppression absolutely is needed as well to provide total assurance, which is the journey that we're currently on now. So thank you for listening to where we currently are with certification for lithium fire suppression.
Thank you very much, Rob. And Paul, I don't know if you're going to join us visually, but please come back orally. I don't know if you're still having issues with your connection, but welcome back. Now, we have had a lot of questions, so I think we're only going to be able to scratch the surface, but let's see how many we can get through. And I will start with one for you, Paul, which is quite a simple question to ask, but I suspect it might be a complicated one to answer. And that is, can lithium-ion battery fires be extinguished?
Actually, the answer is quite simple. Yes, it can. But there is a but, as you expect. It goes back to earlier in my presentation where, as I mentioned about the fact that these batteries are essentially in a metal box, if we're talking about EVs in particular, and indeed e-scooters and e-bikes. So there are products out there, certainly, that I've experienced that will extinguish a lithium-ion battery and prevent thermal runaway from continuing on. And I've experienced that myself. There is that difficulty of being able to apply it in the right time and the right way in something that's designed to keep water out or liquid out. So yeah, it is possible, and they do exist.
Yeah. And do you think that might perhaps be behind why the questioner is asking if they can be extinguished? Maybe it's the difficulty of actually getting to the point where you can extinguish the fire.
Yeah, possibly. I think ultimately, as I said before, industry will always find a way. Where there's a market, there'll be a way found. My experiences so far is that the industry has found a product or made a product that will extinguish fires in lithium-ion and, as I say, prevent any reignition and stop thermal runaway. The next phase, when it comes to vehicles, because obviously the largest, most high-profile issues that we have in terms of lithium-ion battery fires are in vehicles. Next phase is how you get that into the battery compartment itself. And you know, we've talked about I talked about lances as a potential and all those sorts of things, but they're not necessarily easy to get, you know, into a battery compartment. You have to go, well, first of all, you've got the fire itself. Then you, in terms of the vehicle, because obviously the vehicle catches light, using that as an example. Then you've got to be skilled enough to get the lance through the vehicle chassis body, that's then got to go through into the battery, which you can easily do. But then you've got to know when to stop, so you don't go through and out the other side, and then be able to release the extinguishing fluid that you've fully researched and worked. So it's a huge process, potentially a huge investment for fire and rescue services that they may not have the funds at the minute, and they may not have the number of calls at the minute to realise that amount of research and investment that they've got to put in. So it's there's a long way to go, but it can be done.
Great, thank you very much. Rob, I'll come to you next. What's industry doing in terms of legislation, both within Europe and the UK, to help make them a safer place?
I touched on the battery regulation and how certification bodies are providing certification for batteries. That document does provide requirements for the actual safety of the battery. I know that a lot of the mandated parts for notified body requirements are actually to do with circularity, but that does still form a document which certification can be offered against for the safety of the batteries. When it comes to suppression, when it comes to regulation, there's not a fire kind of specific EU or a UK kind of regulation in the same way as you might have things like PPE. You do have obviously statutory instruments like the Fire Safety Act, and from our part, I think what industry is doing, if we reflect on the standards bodies, we're investigating and creating standards, and then the certification bodies are also developing certification schemes so that those individual products can have certificates that say these items comply and these items do a certain thing, and that would help form part of those risk assessments. And it's also useful to also talk about a lot of the special interest groups, a lot of the kind of knowledge sharing that's going on. Obviously, Institute of Fire Engineers, FIA, and FCC, they're all groups that are investigating this kind of thing. And then you've got the Electrical Safety First Bill as well that's going to Parliament for awareness for things like e-scooters. So there's a lot of stuff going on at the moment.
Yeah, evidently, yeah. Thank you. Back to you, Paul. Do you have any opinion on the use of supposed specific PPE on lithium-ion battery fires?
So could you just repeat that? I just want to make sure I've got the right.
Yes, of course. Do you have any opinion on the use of supposed specific, PFEs, my mistake, on lithium-ion battery fires?
So not necessarily specific, no. But again, there are a number of developments in industry around PFE. So there are equally there are liquids that will prevent thermal runaway if injected into the battery at the right time. So this is other areas of research that I'm aware of. So nothing that I can say here specifically, but again, that development is happening, and I'm aware of one that's being tested and has demonstrated a great deal of success.
Yeah. Thank you. Rob, what about distances between containers for grid scale batteries? Can these distances be reduced by other measures like firewalls or misting systems, things like that?
I think the minimum is 6 meters, and that's from an FM study, and that's referenced in the NFCC guidance. And I think as well, NFCC requests justification or need justification if that's going to be reduced at all. So yeah, I would think that that's quite perhaps difficult at the moment where there aren't those kind of certified and approved technologies. So there's a couple of considerations, I would think. So one of the things in the NFCC paper, it talks about access for the fire brigades, just being able to move in between the containers. So that's one consideration. So there wouldn't be too much margin to reduce that, I wouldn't have thought. Spacing between the batteries, so I'm assuming these are kind of like grid scale kind of shipping container sort of size things. The way that they're currently extinguished when they do catch fire has been just to put copious amounts of water. I showed a couple of images, I think, in my slides, one for the fire in Liverpool, that one took 11 hours, and then another one on one of the earlier slides, that was a bigger fire in Australia, and I think that took 2 days to extinguish. Both reports were about the fire brigades using copious amounts of water to extinguish it, to, well, contain it, so for a controlled fire. There's all sorts of issues with runoff of kind of dangerous chemicals into the water supply, lots of gas and lots of horrible stuff emitted to the atmosphere in that controlled fire. I think some reports of fire brigade suffering kind of inhalation issues with those kind of nasty gases, and I've experienced some of the those kind of horrible gases as well. So yeah, I would say that absolutely additional things are certainly would be beneficial, but perhaps not to reduce the gaps in between them if that's an additional measure to stop spread from one container to the other. And something else as well that might be a consideration is the individual the separation between the individual battery packs actually inside the container as being suitable prevention methods and suppression with in there as well. Because when I mentioned, I used the phrase like a domino, or it's really like a snowball effect when you get that cascading from one to the next. So one of the strategies that might be employed is to stop the spread from one battery pack to the next, rather than containing it on the actual kind of external kind of grid scale and then spread to the next. So yeah, I think at the moment, without certified kind of products to really lend to the case to reducing the distance between those containers, I think perhaps the distance is quite important, and some consideration perhaps should be made to internally how to stop that fire getting out of hand in the first place and propagating.
I would guess that your point about firefighter access is probably a key one as well, because regardless of any advances in technology or materials, people tend to stay the same size. So as long as firefighters need access, there's a kind of minimum that it can ever get down to.
Yeah.
Right, Paul, back to you. And this, I think this relates back to the point you were making about recycling depots and the fires there. So this question is just interested to hear about any solutions for waste depots that local authorities could use, because there's been a significant increase in fire-related incidents. And they've also asked about EV charging and fire-related incidents. So whether it's possible to cover that in the same answer, I don't know, but perhaps start with the waste depots and any solutions that can be used there, if you could, please.
I think in a really simplistic way of answering this, you could sum it up with awareness in all areas, really. Public awareness, manufacturing. When it comes to for example, the vapes. Just use the vapes as a very quick example. Disposable, literally designed to be a throwaway item. But what do people do? They buy them, they use them, they throw them away, which is perfectly acceptable. That's you couldn't argue against that. What happens once it goes into the bin and then is sent off into the refuse vehicle, which is obviously crushed in the back of that vehicle to enable them to put more and more refuse into it before it goes to the recycling centre. and then it's tipped into the recycling centre, and it's worked out from there, and it goes through various machinery. And it's hardly surprising that there are a number of fires, a large number of fires that have been started by the careless, let's just say disposal of lithium-ion batteries, or items with those batteries in them. It isn't careless because they haven't done it willingly. It's designed to be, in that case, disposable. So I think there's a huge amount of work that needs to be done in terms of informing the public about the dangers of lithium-ion batteries, the consequences of careless disposal, let's call it that then, the charging and the purchase of these batteries. I know people that have got Makita power tools, and they'll go online potentially and buy a looky-likey battery that is not a Makita battery, and there's no amount of trying to convince them not to do that I can do that would stop them, because it's cheaper. And so there's a certain amount of convenience for people and those things that are involved. So it's a huge amount of awareness that needs to be ramped up in pretty much every area of lithium-ion batteries. And just touching on the charging side of things that you mentioned there for EVs, it's a case of how you charge it. I mean, it's not always convenient to plug it into the mains in a domestic setting, because for lots of people, it's just not quick enough to charge a vehicle to get to where you want to be. Where the charging points are placed, whether that's in a Tesco's car park, or whether that's in a domestic setting or a multi-storey car park, or anywhere actually, there's a huge amount of awareness needs to be put in place for that. Everything that you talk about with regard to the safe use, the safe purchase, and the safe charging, don't use looky-likey chargers. Just because the battery connection fits doesn't mean it's the right charger for that battery. There is just so much. It's huge, and pulling it back down to the basic one word, awareness. I think that's what you can do.
But perhaps to bring some hope on that subject, we have seen a huge change in attitudes recently towards things like plastic bags in shops and disposable cups in coffee shops, plastic straws. Obviously, they're not eliminated entirely, but there's definitely been a growth in awareness and some conscience of these things, and the usage of them is so much less than it used to be. So maybe that does set a good precedent that we can do something to increase awareness of proper battery disposal.
The IFE is certainly doing its piece in that. I mean, I wrote to the OPSS, Office for Product Safety and Standards, government department, explaining our concerns around the sorts of things we're talking about with regard to lithium-ion batteries. I've met them a couple of times now, and we're in their regular meetings to talk about these sorts of things. And we're providing information where we can, and advice where we can, and some guidance where we can, to try and steer this awareness, in the right direction. So, government departments are aware that there is an issue, and they acknowledge that, and they're working toward trying to educate the public and industry. So it is happening. It's just we're behind the curve.
Yeah. A related question. What's the correct way to dispose of a battery after a fire? I mean, is it just the same as a non-fire damaged battery, or are there sort of special considerations?
Yeah, special considerations when it comes to after a fire. I mean, it's deemed to be hazardous waste, and so therefore you need to get specialists in to dispose of it at that stage. Even before the fire, it still needs to go to a proper recycling centre that's capable of recycling lithium-ion. So, but certainly, you've got a fire itself, a battery that's involved in a fire. But if the fire brigade have been called and they've, as Robert said, applied copious amounts of water, you've got all of that water runoff that's going into the water courses as well. So the Environment Agency needs to be involved. It's a huge subject that needs to be considered when it comes to batteries that are involved in fire.
Thank you. Rob, you've mentioned some fires that took place in car parks. So what can be done to make underground car parks safer, and particularly with those that might have EV charging within them?
Yeah, I mean, at the moment it's very much kind of at the investigation stage. There is a government guidance paper on this. There's a FIA special interest group, and I believe British standards in development for this as well. But yeah, I mean, very much at the kind of investigation stage. I did this specifically for underground parking, for parking in general, for overground parking. One of the additional issues is just the actual weight of the cars. The average weight is a lot higher, so that affects the structural integrity of multi-story parking. And even then, just considering basement parking as well, one of the issues is just cars are bigger, a lot bigger than they used to be. Places where there's basement parking typically is space is also a premium, if we're considering places like London. So I think that spacing between cars, I mean, you saw from Paul's slides how you can get shoots of flames out the side of cars when they do actually go to them run away. So it's always just stopping one car spreading to the next is really important. And then I know following the disaster at Luton, there's considerations for, you know, are there requirements for suppression systems, that sort of thing. But very much something that's at the investigation stages, I think it's best to say, rather than definitives.
Thank you. And actually, this is to either of you as a final question, either or both for that matter. Would you recommend trying to fight a fire with current? I think that the question probably is referring to, you know, mobile fire extinguishers. Would you recommend trying to fight a lithium-ion battery fire with current fire extinguishers, or leave it to the professionals?
I think from my perspective, if it's a, you know, in a vape, then yes. I mean, you know, obviously notwithstanding depending on where it is, and, you know, get out, stay out, call the fire brigade out. Obviously that's the standard, you know, advice, and I stick to that advice. But if you find yourself in a situation where you feel that you're willing to give it a go and capable, and you can still exit, and, you know, it's necessary, certainly nothing big, you know, and certainly not with conventional extinguishing media. You know, it's pretty ineffective against a lithium-ion battery fire. If it helps you escape, then certainly, you know, but not in a way of it extinguishing the fire. No, personally.
Yeah, so yeah, just to add to that, yeah, absolutely. We certify products that may be used by general public, or people who have specific training in like a kind of work setting, and we're just proving that equipment, if used, will work. But ultimately, yeah, the advice from the fire brigade, I think, is to, you know, escape safely, and, you know, a personal risk assessment.
Great. Thank you. Well, unfortunately, that's all we've got time for today. Given the number of people who registered to attend this webinar and the number of questions we've received, and I'm sorry we haven't been able to answer all of them, you know, it is clearly a topic that there's a great deal of interest in. I'm very grateful to Paul and to Rob for their clear and comprehensive presentations on lithium-ion battery technology and how fires develop, and on testing and certification options that are available to try to reduce the likelihood of a fire breaking out. And I hope you'll agree that they gave some very helpful answers to interesting and relevant questions. Fire safety for lithium-ion batteries is very much a developing area. There's a lot that will be done on the future to address this challenge. There is work ongoing on developing standards in this crucial area, mainly at the European and international levels at the moment. For example, CEN TC70 is looking to create a new part of the EN3 series that will provide tests for extinguishing small lithium-ion metal battery fires, while ISO TC21 is considering introducing a new classification for lithium-ion and lithium-ion metal battery fires. There are also some other proposals that are at an even earlier stage than these, but at present, most of the work is focused on fires in small batteries, such as those on those in a phone or a vape. British, European and international standards are developed through consensus, and we welcome and very much encourage all stakeholders to participate. Anyone with an interest in the subject can apply to represent what we call a nominating body, so your trade association or professional institution. But we also want you to comment on standards, those that are under development. All standards have to undergo a mandatory 2-month public consultation via our online standards development portal, and anyone can comment. It's free, you just have to register on the SDP. So when relevant standards go out for consultation, please do make your voice heard. We do really want to hear from you, and standards can only be successful if they represent the consensus of those with an interest in a particular area. So thank you once again to Paul and to Rob for their excellent presentations, for Sam to making it all happen behind the scenes, and for all of you, to all of you for attending and submitting some very thought-provoking questions. We look forward to welcoming you to some other webinars in the future, and on screen you'll see there are 2 coming up during Net Zero Week at the end of September. So one on climate resilience of UK assets through standardisation, and another on environment law and biodiversity net gain for the built environment. And hopefully either or both of those will appeal, and we hope to see you there. Thank you very much, and goodbye.